Hello, grade 9, Tanasoff, Gates, Hollerith, Hopper, Iverson, and Neumann. Okay, I hope I did not forget anyone. This is Sir CJ, and this video intends to guide you, my grade 9 students, in finishing your learning activity sheet for the fourth quarter. Okay, so in science, as we all know, we have started talking about projectile a long time ago, but these videos, this series of videos, are going to be intended for you so that you won't just pass through this quarter without really learning at least what these major topics are about. Okay, so ang intention ng mga video lessons na to also is to provide you with a very productive way of spending your online classes because we still have a couple of weeks remaining naman for the fourth quarter. Okay, so for quarter 4, weeks 1 to 2, this is your learning activity sheet anyway. I know that you're familiar with it, pero for those who are not yet, this is your learning activity sheet. And the reason why I'm using this, it's because para makareceive kayo ng full instructions on how to proceed and how to answer your LAS. Actually, I have a PowerPoint presentation version of this. However, if I'm going to use that, you may end up rummaging or baka mangalkal pa kayo sa LAS ninyo at mag-identify pa kayo, mas stress pa kayo mag-identify kung alin ba doon yung ibig kong sabihin. That's why I'm just using this here para talagang diretso kung ano yung tsura niya, yun na siya. Okay, this discussion is also going to tackle certain things that are in need of correction in your LAS. So just stay tuned for that. Okay, so for the first one, you have to write your name, your section. So if you're an Atanasoff, Gates, Hollerit, Hopper, Iverson, and Neumann. Ayan. You have to write the date as well when you started answering or working with this part. For quarter 4, weeks 1 to 2, projectile motion, the background of the lesson. Okay, so we have discussed that in basketball, these players right here, as they are drawn right here, they are of different distance from the hoop. So for them to successfully shoot the ball, they have to make sure that they exert the right amount of force, which will send the ball at a particular initial velocity and that it reaches the hoop or maybe hit the back of the back of that box right there sa may backboard and then bounce towards the hoop. Nevertheless, this is a simple application of projectile motion, and I think that in our discussions we also gave several other applications that are more controversial. As I told you na rin, in wars, I mean guns, the concept of bullets being shot, ayan, mga missiles, ayan. So they're launching are along a projectile. Okay, so a projectile is any object. Kung missile man yan, missile lang siya habang, as it is. Like, fundamentally, it's a missile. Pero once the missile is set to launch, sa mismong flight niya, that it became a projectile. A ball is a ball, as it is, pero once it got launched, it's gonna turn into a ball that is also a projectile at the same time. Projectile is an object upon which the only force acting is gravity. Again, let me clarify that this LAS is not written by your teacher. Okay, it is also written by the division office. So there are some corrections that we need to correct here. In projectile motion, we don't just actually consider gravity. We're also considering initial velocity. Okay, so yung force as well that brought that kind of initial velocity, we're also considering that. Though gravity is playing a very important role, hindi lang naman siya talaga yung force na nagpa-play ng role dyan. Okay? Okay. A projectile motion is also further explained downwards here. And then examples of projectile motion are the following. So, in basketball, in volleyball, actually not just in service, no? When even though na in spike siya, it can also actually be or it can actually look like pa rin a parabola. So, it can also be a projectile, hindi lang siya sa service ng volleyball. Also, the dropping of relief goods from a helicopter, that is also considered projectile. And then batting a baseball. The first kind of projectile discussed here are horizontal projectiles. It's called horizontal projectile because it's launched horizontally. Okay, ito siya. As you can see in this example, itong bola na to, ni-launch siya horizontally. So, it was made possible by putting the ball on a high place already. Okay, and then from that place, it's gonna be pushed off that place horizontally. The force was applied horizontally. Tandaan mo, yung horizontal is pahiga. Okay, just look at the horizon. Ay, yung point na nagmi-meet ng langit at ang lupa. Ayan. Okay, yung langit at karagatan. And that is going to help you remember horizontal. Okay, so in that case, wala siyang initial vertical velocity. Okay, so meron lang siya initial horizontal velocity. Yung kanyang horizontal motion is due to the direction of the initial force that was applied to it. I clarified that already kanina. Horizontal siya kasi horizontal din naman yung direction ng force na in-apply sa kanya. Ngayon, the combination of the sige, before we go there, it's launched horizontally, pero once it got into this trajectory right here, it's gonna have already both the horizontal and the vertical components of its motion. Okay, the combination naman of those horizontal and vertical components is going to be projectile motion, and the path is going to become a trajectory. And that trajectory looks like half of a parabola if you're gonna take a look at it. And if you're gonna take a look at it closely. Okay, notice that the horizontal motion of the projectile does not change throughout its trajectory as the distance in every position is the same. It doesn't change. Okay, so let's move to the next page. Okay, so may mga several tayong mga quantities na kailangan to consider when it comes to projectile motion. Ang una sa lahat is the maximum height. In this LAS, it is I think it's not formatted well. Okay, pero the maximum height and the horizontal distance. So dy maximum height is dy, and then the horizontal distance, which is dx, they can be calculated using the formulae for the freely falling bodies, and that for constant speed motion respectively. So itong dy is equal to gt squared over 2. That is the formula for free falling bodies, and it could be used for the for the vertical distance, itong maximum height. And then yun namang para sa horizontal distance, you can just use the simple speed formula, which is speed is equal to distance over time. Kaso dito, dinerive na lang natin siya. Okay? So, ito, original nito talaga is speed, like V is equal to D over T. Pero since dinerive na nga natin siya na dapat D nasa labas, ayan. So, D is equal to VT na siya. Yung T dito is time. Yung G naman is the acceleration due to gravity. And then yun namang V is the velocity. Okay. The horizontal distance or range of the projectile is, ayan, as it was explained already a while ago. Okay, now for the now we're done with the distances. Let's now go to the speeds. Ayan. So for the vertical speed of the projectile, it can be determined using different equations. Iba-ibang equations ang pwede natin gamitin. Kapag halimbawa, given yung time nung pag-fall niya, remember this is still horizontally launched projectiles na. Ayan. So, we're still talking about that. Okay, so if that is so, what we'll be using are the following. So VI or velocity, Y or that is vertical velocity or vertical speed is equal to the initial velocity along the vertical or the vertical initial velocity, VIY, plus GTY. And so if halimbawa wala naman siyang initial velocity, you can just scrap VIY and then just proceed with, you know, GT. So multiply them na lang. Now, for the vertical velocity, it can also be computed using the vertical distance covered. Kasi halimbawa walang time na binigay. Ayan. So, distance na yung binigay. You can use Vy is equal to Vi, the square root of Vi squared plus 2GDY. Or kung again, wala namang initial velocity, you can just scrap it and then just stick with 2GDY. So, that's the square root of 2GDY. Okay? Okay, now let's proceed to the time. Okay, so again, started with distance, that's velocity, and then time. The writers of this LAS suggested that we should be using the square root of 2 dy over g to get the value of time. Okay, so the time of fall depends on the vertical distance covered, and the equation can be derived from the vertical distance equation. Ganun siya. Now, we don't really solve for this. We don't solve for for final velocity of the projectile. Pero, it's just worth mentioning that it is the velocity of the projectile before touching the ground. Okay, pero we can calculate it pa rin based on the vertical and horizontal speed. Kaya pa naman yan. Okay. It's just not really going to be like VF. So parang VY pa rin siya. I mean, VY and VX pa rin naman siya. Okay. Remember that in projectile motion, there will always be the horizontal and vertical components as shown in this figure. Okay, so the resultant force or VR is, say, for instance, going this way. It surely will have a Vx and a Vy. Okay, now for the sample problem. For the sample problem, this is quite problematic because the final answer is incorrect. Okay, so let's just fix that. Jonathan claims that he can throw a dart from a distance of 3.5 meters and hit the 5 centimeter wide bullseye. Now, if he throws down the dart horizontally with a speed of 15 meters per second, and he starts to throw at the same height as the top of the bullseye, can Jonathan hit the bullseye? Well, the writers did not give us a schematic, so maybe we can just, I suggest that you yourselves try to try to draw it down. Okay, tingnan nyo kung ano magiging tsura nun. Like, he threw the dart horizontally, tapos it is aligned with the aligned with the top of the bullseye. Okay, so is it possible to hit the bullseye? If that is so, ayan. So you have to draw the schematic na lang yourself. The givens are the following. So the horizontal distance is equal to 3.5 meters. For the initial horizontal velocity, it's 15 meters per second. Again, mali lang yung formatting dyan. And then for the acceleration due to gravity, it's 9.8 meters per second squared. What we need to find are the following. So dy, which is vertical distance, and then total time. For the solution, hindi rin in-specify ni na writers kung ano yung dahilan kung bakit yan yung kung bakit yan yung gagamitin ng formula. But you can assume that that is the formula we'll be using because given naman si Vix at saka given naman si dx. So we can just derive a formula for time, which is very easy. It's time is equal to dx over vx. There, ito siya. Okay. And then, you just have to substitute the values. I don't know why it's right here, pero yeah, the answer is 0.23 hundredths. It's 23 hundredths seconds. Okay, so since di rin tayo binigyan ng cue na it's part 1 pa lang yon. Yes, people, it's part 1 pa lang. That's not yet the answer. Remember, we're still looking for dy. And yeah, we're looking for dy. We got time. Now that we have determined the time we can solve for dy, in this computation, what we're supposed to use now is dy is equal to gt squared divided by 2. Okay, so if we are going to look at that, you're going to multiply 9.8 meters per second squared by 0.23 seconds and then divided by 2. You are not going to get 2.45 meters. I think you're going to get 0.26 meters, and that is going to be our correct answer. If you got a different kind of answer, or if you were able to solve for this correctly and you got like 2.45 meters, you can always message me. Okay, we can discuss that. But so far, when I confirmed it with your math teacher too, we had the same findings. It's not really going to be like that. It's not gonna be 2.45. And then the conclusion here was that Jonathan is going to hit the bullseye. Now, that the flight of a projectile can be described in terms of its horizontal and vertical components. So when solving projectile motion problems, kailangan daw is to resolve the velocity of the projectile into its components na horizontal and vertical. Remember that, okay? Okay? Always remember that. Okay, we're done there with the first kind of projectile, which is projectiles that were released or that were launched horizontally. Let's now move to projections at random angles. These are full parabola, mga full parabola ng mga to. Ayan, so may start talaga siya tsaka finish at the same height. So, start at this height, and then soar high, and then go back to that height. Ganyan yung mga ganyan yung mga projectiles na to. Okay, so they're going to travel both vertically at saka horizontally as it's seen in this graph. Now, when the projectile is fired with an initial velocity of or vi at an angle theta um, above the horizontal, this is how we should be solving for them. So vix, or the initial velocity along the horizontal, is equal to vi cosine theta. And then for viy naman, you have to use sine theta. Okay, so yung mga projectiles na yan, they always experience a constant vertical acceleration dahil nga sa pull ng gravity ng planeta natin. Hence, the vertical displacement or dy and the vertical velocity, they can be resolved by using the formula for uniformly accelerated motion where dy is equal to viy plus gt squared over 2. Our writers derived the formula, which is dy is equal to um, v2 fy is equal to v2 iy divided by 2g. And then, without showing us what was cancelled and why dy became vfy, we got now vfy is equal to viy plus gt. Okay, so again, the task lang naman of this video is to give you these instructions. Much of this you have to listen to me in our actual discussions. Okay? Okay. Pero ganyan siya. I'm going to let you know how what happened there. Pero right now, what the last is suggesting to us is that this is how it was derived. Okay? We will be exploring more references aside from this that explains it better. Now, as the projectile rises, it decreases its vertical velocity. Now, it's a good point. Ang mga bagay na tinraw, halimbawa na lang, tignan natin ito. ang mga bagay na tinrow, na hinagis, kapag yan hinagis mo siya pataas, unti-unti yan babagal. Okay? Babagal yan. Kasi ano siya, it's moving against gravity. So talagang babagal yan. Tapos makaka-reach siya ng point na ano na lang siya, na magzi-zero siya, titigil siya sa ere. Tapos since tumigil siya sa ere noon, uh, babagsak naman siya. So it's not going to drop like this, no? It's not going to drop like ganon, point blank, hindi ganon. Ang pagbagsak niya is still being affected by its vertical velocity. So, gaganon talaga siya. So, pagpagsak niyan yan is due to gravity. Yun yung point niyan. Okay. It decreases its vertical velocity, and then at the peak of the trajectory, it becomes zero. Thus, the time for the projectile to rise can be solved by the equation Vfy is equal to Viy minus gt. Okay. The acceleration due to gravity is negative dahil daw it's going against the pull of the Earth. Okay. Now, it says here where Vfy is equal to 0 or 0 is equal to Viy minus gt. We don't really know, I mean, I won't blame you if you don't get it right there, okay? Kasi the writers did not really expound on that. There was no continuity. We can't really understand what happened there. Yes, okay. I understand your frustration. That's why in the class discussions, we are there to help you out. Okay. Again, these are instructions on how to proceed with the last. Okay. Okay. So for the full discussion on this, expect that it's gonna be given in the class discussion. So you better take the opportunity once you're there. Now, let's transform the formula into the formula of time daw. So, gt is equal to Viy minus gt plus gt. Why is that so? Gt was added here on one side of the equation, and it was also added to the other side of the equation to cancel it out. Okay, so it was transferred to the other side of the equation. It became gt is equal to Viy. Now, to set aside to make time alone on one side, we have to divide both sides by g. So it cancels out g on this side. Yeah. And then t is equal to Viy over g. Now, Viy, as we know it, is also equal to Vi sine theta in the case of vertical initial velocity. Okay, so in the case of VIY, kanina, remember, it's equal to VI sine theta. Yung VIX naman, it was equal to VI cosine theta. Remember? Okay, now you just have to put it here. Okay, now for the projectile beginning and ending at the same height, which is basically projectiles that were projected or launched at some random angles like this. Okay, so I really don't get why they have to say that muna. Pero, yeah. We're basically just saying the same thing here. Okay, the time it takes to rise to its highest point is equal to the time when it starts to fall from the maximum height or the highest point. So, sabi niya lang naman dito is yung time nung pag-rise niya. Ito, yung time na para makapunta siya from this point papunta dito sa point na to is equal to the time para daw na-tinake niya from this point papunta doon. So, if it's 5 seconds, that's also 5 seconds. So, it's a total of 10 seconds. It's a 10-second flight kapag ganun. Okay. Thus, doubling the time will give you the total time of flight and the projectile in the air. So, TF, or the final time, is equal to 2T. Tutti frutti. Okay. Now, we can combine the formula by putting 2vi sine theta over g. Saan po galing yung buong formula na yan? It's this one. Remember that time is equal to vi sine theta. So, since 2t is 2 times, so you just have to put them like vi sine theta over g times 2. So, yun lang siya. Okay? Now, the maximum height or dy can be calculated by considering the downward motion of a projectile. So, yung downward motion niya is when yung initial vertical velocity is equal to 0, it's from the peak. So, dy is equal to VIYT plus GT squared over 2. Okay, tapos since this is 0, you're gonna get dy is equal to GT squared over 2. Now, combining them with the formula of time in the y-axis, you'll be getting dy is equal to uh, g over 2 and then VIY sine theta squared over g. Okay, so simplify the equation. Everything is in chaos. Okay, this is not properly formatted. It's not correctly formatted. But the ending of that formula is going to be dy is equal to VIY sine theta squared. And then you have to divide that by 2g. Well, 2g is always 19.6, so you can just put 19.6 here. The horizontal displacement, known as r, of the projectile is the product now of the horizontal velocity and the time of flight. Um, it's horizontal initial velocity in this example. Pero sige, let's forgive that. Um, Vix, as we remember, is equal to Vi cosine theta. And then Tf is equal to Tvi sine theta over G. Where did that come from? Again, asan na ba yung time kanina? Eto siya. Okay, so, ayan siya na. 2Vi sine theta over G. Okay, so, hope I explained that. And now you're just going to multiply them. So you'll be getting vi squared and vi squared 2 cosine theta sine theta over g. That's equal to r, or the range, the total amount of horizontal distance covered. The range is this one. Ito siya, no? Itong halimbawa, from 0 until 10, that's the whole range nitong isang to. Ito namang pinakamalayo is 0 to 20, that's the whole range. That's what we're solving for. Okay? Okay. Now, since sine 2 theta is equal to 2 cosine theta sine theta, what you'll be getting here is going to be r is equal to vi squared 2 sine theta. Okay, so we just basically have canceled out cosine theta. Okay. Um, over g. Okay, so I hope that this is not turning so far into a very big chaos for you. Kaya nyo pa naman ba? Don't worry, this is just not gonna last forever. Okay, so Jenna is a long jumper. She leaves the ground at an angle of 50 degrees to the horizontal and at a speed of 9 meters per second. So, gaano daw siya kataas nag-jump? If if Jenna jumped, ang tinatanong dito is, ito, gaano kataas yung jump niya? Gaano kataas yung peak niya? Kung sakali man, yeah, ganun yung mga variables niya, yung mga givens niya, ganda kataas yung pag-jump niya. Okay, so the givens are 50 degrees at saka 6 meters per second. What we're looking for is the range and the final time. So for the solution, the writers actually gave us the formulae right here, as in like as they are. Um, But what we don't really fully understand at this point is the formatting. Okay, so I think we have a problem with the formatting right here. Okay. If you're at this point now of your classes, I am instructing you to listen to the discussion. We'll be correcting that. For the DX, what we're supposed to actually focus on is ito no? Sige, dx is equal to Vix and then multiplied by Tf. So, Tf is equal to cosine, no, Vix is actually equal to Vi. This is 6 meters per second. Cosine theta, which is cosine 50 degrees. Multiply that by 0.94, which is not shown here. Okay, so, okay. The result now of this whole, of this entire solution, of this entire writing right here is 0.94. Okay, we will be doing the solution ourselves, no, in our class. Okay, so 0.94. And then they just took the cosine 50, and it's a 0. People, my instruction for you is when you're getting cosines or sines, no, if it's possible talaga, just please include four significant figures. Okay? Okay. And then they just multiplied everything. And then they got the range is 2.86 meters. Okay. For the range, wait lang. That is dx. Okay. So they took time, they took dx, and then that is still different from the range. It's not actually the same amount, isn't it? Okay. So for our discussion, let us also correct this. Kasi dx, the total distance, horizontal distance, was assumed to be of the same, like the horizontal displacement known as range. Yes, this is quite misleading you. Also, in this kasi, like it's taken as one. So let us try to fix that in our discussions. Okay? I told you, okay, this is just me giving you instructions so that you know what to do with your lasses. Even para maumpisahan nyo na talaga silang magawa ng portfolio. Now, these are the key takeaways of this late learning activity sheet. Horizontal motion, it's constant velocity equation for the x component only. Well, not really. We have also some equations for the y component. We just have to identify a particular point. Okay? Pero the following are the equations. For vertical motion naman, constant acceleration equations for the y component. Meron din naman sa x. Meron naman tayong matasolve for x there. And then, constant acceleration has a magnitude of 9.8 meters per second squared. And these are the formulae. So, for weeks 1 and 2, the learning competencies are describe the horizontal and vertical motions of a projectile, and then investigate the relationship between the angle of release and the height and range of the projectile. Okay, now. The following are the explanations for the activities kung paano yung sila gagawin. Okay, so listen carefully. For activity number 1, which is know me well, you have to just answer these questions like as short as you can, as concisely as you can. So you have 1, 2, 3, 4 questions, 5. Okay, 5 questions to answer. Make sure that you just answer them as concisely as you can. You don't have to write essays. Now, what do you do with your answers? You have to take a photo or a screenshot of your answers. There's no need for you to check them. You have to paste those photos or screenshots on your portfolio for quarter 4, weeks 1 to 2 um, slides. Okay, so in your portfolio, kailangan mailagay nyo ito dun sa week 1 and 2 slides niya. Next, for activity number 2, try it now. You have to solve for the following problems and you also have to show your solutions. However, I am not requiring you, okay, at least this is the latest instruction. I am not requiring you to do this activity um, because I need to give you other word problems. Okay, I designed word problems for projectile motion. Please just skip this activity. And then for activity number 3, fill me in. Solve the given problem and complete the table below. So you just have to show your solution. For this one too, you don't have to do this activity. I am going to give you a different kind of worded problems for this. Okay. So, that ends our quarter 4 weeks 1 to 2 last instructions. Okay, meron siyang konting discussion, I know, pero I mean lecture, pero it will be better if you just listen and participate in our class discussions. Okay, so I hope that the instructions are clear and that you are ready to go back to your modular tasks or to our online session. This is Sir CJ. Make sure that tawag doon, you complete this video so that I don't have to repeat my instructions pa. Okay? Okay. Bye.